day 19. Make sure you have lesson 12 out. Hopefully this one won't be as long as the last lesson that we did. You know, we'll just have to wait and see. There's a lot of information in these lessons because it is building your foundation of algebra. Alright, so we've been talking about properties. So, guys, let's look at this opening exercise. Why should the equation x minus 1 times x plus 3 equals 17 plus x, and x minus 1 times x plus 3 equal x plus 17 have the same solution set? What property tells us that they should have the same solution set? The commutative property. Alright? The commutative property tells me that 17 plus x is the same thing as x plus 17. Why should the equation x minus 1 times x plus 3 equals 17 plus x, and x plus 3 times x minus 1 equal 17 plus x have the same solution set? Once again, the commutative property. X minus 1 times x plus 3 is the same as x plus 3 times x minus 1. Do you think the equation x minus 1 times x plus 3 is equal to 17 plus x, and x minus 1 times x plus 3 is plus 500 equals 517 plus x should have the same solution set? And why? Well, look at this. What changed? The only thing that changed was I added 500 here, but then look here. I not just have 17 anymore, I have 517. So yes, because 500 was added to both sides. Alright? So because 500 was added to both sides, then I should still have the same solution sets. Excuse me. Do you think the equation x minus 1 times x plus 3 equals 17 plus x, and 3 times x minus 1 times x plus 3 equals 51 plus 3x should have the same solution set, and explain why? Well, what did I do on this side? I multiplied everything times 3. What did I do on this side? I multiplied everything times 3. So yes, both sides were multiplied by 3. Okay? Alright, so we know that the commutative and associative properties hold for all real numbers. We also know that variables are placeholders for real numbers. And the values assigned to a variable that make an equation true is the solution. If we apply the commutative and associative properties of real numbers to an expression, we obtain an equivalent expression. So in other words, if I'm using the properties, as long as I'm doing it to everything, I'm going to have equivalent expressions. Therefore, equations created this way consist of expressions equivalent to those in the original equation. In other words, if x is a solution to an equation, then it will also be a solution to any new equation we make by applying the commutative and associative properties to express that equation. Alright? Exercise 1. Use the commutative property to write an equation that has the same solution set as x squared minus 3x plus 4 is equal to x plus 7 times x minus 12 times 5. Well, what can I do? Using the commutative and associative property tells me that I can rearrange this in any way. So I can do negative 3x plus x squared plus 4 is equal to x plus 7 times x minus 12 times 5. I didn't change anything except for the order in which I'm adding them. Use the associative property to write an equation that has the same solution set as x squared minus 3x plus 4 is equal to x plus 7 times x minus 12 times 5. Guys, associative property is a matter of just what are you putting together first. Alright, so I can use parentheses to change this just a little bit. I can do it like this. I can do x squared minus 3x plus 4. And then I can do parentheses over here and say, well, I want to multiply those first before I multiply through by 5. Okay? Does this reasoning apply to the distributive property as well? In other words, if I do the distributive property on both sides, is it going to matter? Yes, it applies to the distributive property. Okay? Yes, it applies. All right. Let's go ahead and exercise number 2. Consider the equation x squared plus 1 is equal to 7 minus x. Verify this has the same solution set, negative 3, 2. Draw the solution set as a graph on a number line. We will later learn how to show that these happen to be the only solutions to this equation. So, how do I verify that negative 3 and 2 are the solution set? I plug it back in. Alright, so let's do negative 3. So negative 3 squared plus 1 is equal to 7 minus a negative 3. Negative 3 squared is 9 plus 1. 7 minus a negative becomes plus. So 10 is equal to 10, so that is true. I've verified that negative 3 is true. Alright, let's verify that 2 is a solution. So 2 squared plus 1 is equal to 7 minus 2. 2 squared is 4 plus 1 is equal to 5. 5 is equal to 5, so that is true. It says graph it on a number line. Alright, so since these are the only solutions I have, remember I'm just going to put my 2 dots on the number line, one at negative 3 and one at 2. Let's add 4 to both sides of the equation and consider the new equation, x squared plus 5 is equal to 11 minus x. Alright, so all they did was they added 4 to both sides. So 1 plus 4 is 5, and 7 plus 4 is 11. Are 2 and negative 3 still solutions? Okay, so we're going to plug in negative 3. So negative 3 squared plus 5 is equal to 11 minus a negative 3. That'd be 9 plus 5 is equal to 11 plus 3. So 14 is equal to 14. That is still true. Let's see if 2 is still true. So 2 squared plus 5 is equal to 11 minus 2. 2 squared is 4. So 4 plus 5 is 9 is equal to 9. And that is also true. So yes, they are still solutions. Because, look what I did. I added 4 to both sides. Now let's add x to both sides of the equation and consider the new equation. X squared plus 5 plus x is equal to 11. Now, let's look and see why it changed. So if I add x, I get x squared plus 5 plus x. Look at if I add x to this, my original equation. X minus x is 0, so I only have 11. It wants to know, are they still solutions? So let's look at negative 3. Negative 3 squared plus 5 times, I'm sorry, I messed that up, plus a negative 3 is equal to 11. Well, negative 3 squared is 9, plus 5 plus a negative 3 is equal to 11. 9 plus 5 is 14. 14 minus 3 is 11. Minus 11, so that one's still true. Let's look at 2. So I have 2 squared plus 5 plus 2 is equal to 11. 2 squared is 4 plus 5 plus 2 is equal to 11. 4 and 5 is 9 plus 2 is 11 is equal to 11. That is still true. Because once again, I did the same thing to both sides of my equation. Alright, let's add negative 5 to both sides of the equation and consider the new equation x squared plus x is equal to 6. Alright, so now it says let's add negative 5 to both sides. Alright, so if I add negative 5 to both sides, 5 minus 5 is 0, so I end up with x squared plus x, and 11 minus 5 is 6. So let's see if 2 and negative 3 are still solutions. So I have negative 3 squared plus a negative 3 is equal to 6. 9 plus a negative 3 is equal to 6. So 6 is equal to 6. It is true. Alright, let's check 2. What do you think? Is it going to work? Well, we'll see. 2 times 2 is 2. 2 times 2 is 4. Plus 2. 6 is equal to 6. It's true. Let's multiply both sides by 1/6 and get x squared plus x over 6 is equal to 1. Are 2 and negative 3 still solutions? Alright, so negative 3. So I get negative 3 squared plus negative 3 over 6 is equal to 1. So I get 9 plus a negative 3 over 6 is equal to 1. 9 plus a negative 3 is 6 over 6 is equal to 1. That is true. Alright, 2. I get 2 squared plus 2 over 6 is equal to 1. So 4 plus 2 is over 6 is equal to 1. 6 over 6 is equal to 1. That is still true. Let's go back to part D and add 3x cubed to both sides of the equation and consider the new equation x squared plus x plus 3x cubed is equal to 6 plus 3x cubed. Are 2 and negative 3 still solutions? Guys, what do you think? If I'm adding something to both sides, am I still going to get the same? Are these still going to be solutions? Let's look. So negative 3 squared plus negative 3 plus 3 times negative 3 cubed is equal to 6 plus 3 times negative 3 cubed. Alright, so negative 3 times negative 3 is 9 plus a negative 3 plus 3 times, well, let's do negative 3 cubed. Negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. Alright, so 6 plus 3 times, and we've already figured out that's negative 27. So I get 9 plus negative 3 plus, and now I've got to figure out what 27 times negative, or 3 times negative 27 is. That's a negative 81. 6 plus a negative 81. So 9 plus negative 3 is 6. So 81 minus 6 is negative 75 is equal to negative 75. So that is still true. Let's check 2. So I get 2 squared plus 2 plus 3 times 2 cubed is equal to 6 plus 3 times 2 cubed So 2 squared is 4 plus 2 plus 3 times 2 cubed. 2 times 2 is 4 times 2 is 8. Plus 6 times, is equal to 6 plus 3 times 8. So I get 6 plus 24 is equal to 6 plus 24. So I get 30 is equal to 30. And that is also true. All right, that is also true. All right. Look at exercise number 3. Solve for r if 3 over 2r is equal to 1/4. All right. So in addition, we can apply the commutative, the associated, the distributive properties. All right. Let's talk about what happens when we have something that looks like this. So I can do a couple of different things here. The simplest way for you to do this is to cross multiply. And that would be just like finding finding a common denominator. So 2r times 1 is 2r. 3 times 4 is 12. Divide by 2. R would be equal to 6. Okay? Solve for s if s squared plus 5 is equal to 30. Guys, subtract 5 from both sides. So s squared is equal to is equal to 25. What do we know s can equal? Well, s can equal 5, or s could equal -5. Remember, when I'm dealing with square of something, it could be positive or negative. Solve for y. Guys, the whole part of this lesson has been why we have to do to one side what we do to the other. So if I subtract 4y here, I get -3 is equal to y minus 8. I can add 8 to both sides. Those cancel, so I end up with y is equal to 5. Okay, y is equal to 5. Doesn't matter which step happens first. Alright, doesn't matter which step happens first. Does it matter if I subtract 4y here first, or maybe I could have added 8 first? Does that matter? Alright, so we're going to look at this really quickly. Exercise number 4. Consider the equation 3x plus 4 is equal to 8x minus 16. Solve for x using the given starting points. So, what I want you to do is I actually would like for you to do this for homework tonight. I want you to be able to answer this question. Does it matter where I start? So here it tells me to subtract 3x from both sides first. Here it says start with subtracting 4 from both sides. Here it says subtract 8x from both sides. And here it says add 16 to both sides. So I want you to do these 4 columns for homework tonight. And I want you to figure out, does it matter where I start? Alright? So closing exercise. Consider the equation. 3x squared plus x is equal to x minus 2 times x plus 5 times x. Use the commutative property to create an equation with the same solution set. Alright, what can I do? Commutative property tells me I can rearrange things. And it's not going to matter. As long as I'm not changing the value of anything. Use the results from A and use the associative property to create an equation with the same solution set. So we're working off of what we created here. So now we're going to use that and we're going to use the associative property. So on this side, I want to do the x plus 3x squared. And then let's say on this side, I want to go ahead and multiply the x plus 5 and the x minus 2 first before I multiply everything times x. Using the results from B, use the distributive property to create an equation with the same distributive, or with the same solution set. So, I need to use my distributive property. There's nothing I can do over here. So now I need to multiply this. Alright, I've got to multiply this. I'm going to come over here and do x plus 5 times x minus 2. X times x is x squared. X times negative 2 is negative 2x. X times 5x is 5x. And 5 times negative 2 is negative 10. So I end up with x squared plus 3x minus 10. And now I need to multiply that times x. So I get x cubed plus 3x squared minus 10x. And all I did was I used that distributive property and got rid of all those parentheses there. Okay? Using the results from C, add a number to both sides of the equation. It does not matter what number you want to add. I'm going to add 5. So I get x plus 3x squared plus 5 is equal to x cubed plus 3x squared minus 10x plus 5. Using the results from part D, subtract a number from both sides of the equation. Alright, so I think I want to subtract 3. Okay, so I get x plus 3x squared plus 5 minus 3 is equal to x cubed plus 3x squared minus 10x plus 5 minus 3. And I'm keeping that minus 3 there because I want you to see what I did. Using the results from part E, multiply both sides of the equation by a number. I want to multiply it by 4. Okay? I'm going to multiply it by 4. X plus 3x squared. And I'm going to go ahead and do the 5 minus 3 is plus 2. And then 4 times x cubed plus 3x squared minus 10x plus 2. Okay? Using the results from part F, divide both sides of the equation by a number. I want to divide by 4. I'm going to divide by 4. If I divide that by 4, look at what I end up with. X plus 3x squared plus 2 is equal to x cubed plus 3x squared minus 10x plus 2. What do all 7 equations have in common? Justify your answer. They all have the same solution set. How do I know they all have the same solution set? Because every step that I did, I know that I did it to both sides. No matter what I did it to both sides. All right, they all have the same solution set. All right, guys, remember, reach out if you have questions.